So here's a linear programming example, and I'll be able to start setting it up and then solve it in the next video. It's very wordy. You just have to get through it. You have to read it at least 5 times before you give up. And you have to think about assigning variables, but not right away, because we're going to get to the bottom and we'll see what we can do. We have 180 tomatoes and 15 onions. We're making jars of tomato sauce. So there's our tomato sauce, right? And salsa, which I'm going to put in green. Okay, tomato sauce requires 10 tomatoes and 1 onion. So you can already see here, like here we have 10 tomatoes and 1 onion. We don't have that ratio up here. We have 180 to 15, but 10 tomatoes for 1 onion go into 1 jar of tomato sauce, and we make a $2 profit on tomato sauce. So there's a nice number there that we're going to use. We're going to use all these numbers, but we should really be thinking about this. Into salsa, we put 5 tomatoes and 1/4 of an onion, and on salsa we make a $1.50 profit. Wow, this is good. The person we are making the jars of sauce and salsa want at least 3 times as many tomato sauce as salsa. So look, we have an at least there. Okay, and how much of each salsa and tomato sauce shall we make? Well, if we go right down to the bottom here, we can start, we see the 2 variables, right? We have salsa and tomato sauce. These are the things that we're going to want to find out. So why don't we assign S to salsa and T to tomato sauce, and we are on our way. Okay, and what are the things that we can find out right away from this? And I'll try to work in cyan now. If we have S salsa and T tomato sauce, we know what our profit is. It's going to be 2 times T plus $1.50 times salsa. This is going to be our profit. So I'm just going to write P there. And that's just using these 2 bits of information. And what are the other things that we can know? We know how many tomatoes we'll use if we make T tomato sauce and S salsa, right? Because 5 tomatoes go into salsa, 10 tomatoes go into tomato sauce. We're going to have, and I'll stay in cyan, 10 times T, right? That's how many tomatoes we're going to have. That 10 right there came from there. Plus 5 times the amount of salsa. So that's a 5. Times the amount of salsa. These 2 numbers together have to be, right? The number of tomatoes, we're constrained. It has to be less than or equal to 180. 180, not 180. So well, look, we just used this and that to come up with a constraint. We're on our way. And what about, let's look at this onion line here. Again, if we had T tomato sauce and S salsa, I could tell you how many onions we used. We used 1 times T, right? Then the amount of tomato sauce, we used 1 times T plus 1/4, and I'll write 0.25 since we have a decimal there. I don't know if this is the best thing to do, but 1.25 times S. This number of onions has to be less than or equal to 15. So we have some constraints here. This is very interesting. We're taking all of this information and we're writing it mathematically and algebraically over here. Okay, so what's the next thing? The person we are making the jars of sauce and salsa want at least 3 times as much tomato sauce as salsa, 3 times as many as cans. So how are we going to use this information? Well, our tomato sauce has got to be at least greater than or equal to, right? That's what at least means. Greater than or equal to 3 times our salsa, right there, right? The person we're making jars of sauce and salsa want at least 3 times as much tomato sauce as salsa. Okay, how much of each? So we've just taken all of this information and we've written it algebraically. In the next video, I'll take all this information and we'll put this on a graph and see what it looks like.